If you analyze the question, the mass of the sphere, solid sphere, is given as 100 grams. Or convert into SI unit, 100 into 10 raised to minus 3 kilogram. So overall comes as 10 raised to minus 1 kilogram. Radius of the sphere is given 2.5 centimeters. Convert centimeter to meter again. So 2.5 into 10 raised to minus 2 meters. Even the speed of the sphere is given 10 centimeters per second. That also to multiply 10 raised to minus 2 for meters per second. So overall the value is 10 raised to minus 1 meters per second. Now calculate the total energy assuming no energy is lost. There's a word missing here. No energy is lost. We'll add it later last. Now total energy. There are two kinetic energies for rolling object: kinetic energy of rotation and kinetic energy of translation. So total kinetic energy will be kinetic energy of rotation plus kinetic energy of translation. Now if you calculate separately, kinetic energy of rotation will be half I omega square. Moment of inertia I omega angular speed. Moment of inertia of a solid sphere is 2 by 5 mr square. And we have a relation V equal to R omega. From that, omega can be substituted as V by R. So half moment of inertia is 2 by 5 mr square for a solid sphere. Omega is V by R, omega square is V square by R square. You cancel R square, cancel 2. And finally, the answer will come as 1 by 5 mv square. So this is the kinetic energy of rotation. Kinetic energy of translation, we have half mv square. So if you add both, you get the total kinetic energy. Half mv square plus half I omega square. But I omega square is calculated as 1 by 5 mv square. So you take addition with LCM. 7 by 10 mv square. That's a total kinetic energy. Now we have to just substitute the value of mass and velocity to calculate the result. So 7 by 10, mass is 10 raised to minus 1 kilogram. Then velocity is 10 raised to minus 1, but square, so 10 raised to minus 2. You calculate that 7, then 10 raised to minus 1, minus 2, one more 10 from the denominator will make it 10 raised to minus 4 joules. So that's a total energy, assuming no energy is lost. The second part is ratio of rotational kinetic energy to total energy. So rotational kinetic energy by total energy will be rotation kinetic energy is half 1 by 5 mv square, not half, 1 by 5 mv square. Total we added and got us 7 by 10 mv square. So rotation 1 by 5, total 7 by 10 mv square. Cancel the terms, you get 1 by 5 upon 10 by 7, that will be 2 by 7. That's the ratio. Rotational to the total. 2 out of 7 is rotation. Similar to that, you can find the translation to the total. Translation is half mv square. Total is still 7 by 10 mv square. Get the mv square cancel and get the ratio 1 by 2 into 10 upon 7 will be just 5 by 7. So this is the ratio of translation to the total kinetic energy. You can add and see, it will be just like 100%. So we need to make a note, one, that V equal to R omega, or omega equal to V by R, what we substituted here. Even the moment of inertia, 2 by 5 mr square for a solid sphere. Then the correction in the question, like assuming no energy is lost.